All right, students, so we're working on linear patterns, and the first video here will be one method where you're looking at the start and the growth, and the next video will be looking at a different method for finding the pattern. So the first thing I notice when I look at this pattern here is that it's always staying in an X shape, and that each time we move to the next figure, I'm seeing a few new squares appear on the edges of the X. And so what I'm going to do is mark what the new squares are. So on figure 2, we've got 4 new squares that I'm shading in with red. Figure 3, you can see there's 4 squares that are shaded in like that. So what I can see is that every time we go to the next figure, we're going to add 4 more squares onto it. Okay, so figure 4 would look just like figure 3, except it's going to add on another square in the top left, top right, bottom left corners like that. And we can just continue that process for forever and ever and ever. And so what I'm seeing here is that the growth for the linear pattern is 4. We're adding 4 squares per figure. Then this is a little bit of a weird thing, but when we figure out a linear pattern or most patterns in math, we go back to x equals 0, something we'll be working on this unit. And I see figure number 1 right there. I don't see figure number 0. So one suggestion is write down or draw what figure number 0 would look like. Figure 0 would just be a single square in the middle like that. And so that would be my start value. My start, or my figure 0, has 1 square to it. So I'm going to take that information here, and I'm going to make a little table, a little XY table. X is the figure number, and Y is the number of squares. So we can go 0, 1, 2, 3. There were 5 boxes in figure 1, 9 boxes in figure 2, 13 boxes in figure 3, and only 1 box in figure 0. So I hope you can see how the growth of 4 that we saw visually is showing up right there in the y values as we go plus 4, plus 4, plus 4. In fact, there's a way to write an equation for this pattern, which is y equals 4x plus 1. Now, why is that equation useful? Because if I care about a particular figure number, like figure number 5, then I can go 4 times 5 plus 1, and I'll get the number of boxes. So I know that, for example, figure 5 has 21 boxes, because 4 times 5 is 20, and plus 1 gives me 21. You can also go the other way, where if I said, what figure is going to have 101 boxes, then we can solve for x and go 101 minus 1 is 100, divided by 4 is 25. So I know figure 25 would have 101 boxes. In the next video, I'll do the same problem, but I'll do it in a slightly different way.